In this lesson, we'll discuss how to maximize projectile motion functions. The question reads, if an object is launched at an angle of 45 degrees from a 10-foot platform at 60 feet per second, it can be shown that the height of the object in feet is given by the quadratic function found underneath, where x is the horizontal distance of the object from the platform. We're expected to find the height of the object when its horizontal distance from the platform is 20 feet away, and round to 2 decimal places. Then we'll answer B and C. First, you'll notice that the function h is in terms of x. H represents the height and x represents the horizontal distance from the platform. They want us to find out when the object is 20 feet away, the height. Now, of course, you can use this graph to do that. You can try to predict what the y value of that point is, but that's not practical. We actually have a function that can give us the actual value. And here's how it's done. I'll take this 20 feet, x is equal to 20, and substitute it into my function where I have h at 20 is equal to negative 32 times 20 raised to the power of 2. Notice that I replaced the x with 20. 60 raised to the power of 2 plus 20 plus 10. Now, using our calculator, we can actually substitute this in and find the height at 20 feet. So I have negative 32, parentheses 20 raised to the power of 2 divided by 60 to the power of 2. That's this part, plus 20 plus 10, and we end up with 26.4 repeating. 26.4. Now, what this tells us is the vertical height after 20 feet. So I'll write down feet. Next, in part B, what is the horizontal distance from the platform when the object is at its maximum? From the graph, you can assume that visually it will be between 50 and 70. So somewhere in between 50 and 70 of a horizontal distance will we have the vertical height. But that's not reliable. We need an actual number. There is a formula that works with quadratics, and it looks like this. X is equal to negative b over 2a. Now let me explain this before we continue. This x will give us the x-axis of the vertex. And for this question, the vertex is at its maximum. That's the turning point of the parabola. B and a represent, in the generic formula of a quadratic, y is equal to ax squared plus bx plus c. A and b refer to the coefficients a and b of the x squared and x term. And by the way, this is called the standard form of a quadratic. Let's find out what our b and a are in this equation. So our a will be negative 32 over 60 squared. Essentially everything other than this x. And let's find out what that is. Negative 32. Then we divide this by, according to the equation, 60 raised to the power of 2. And we end up with negative 0.008 repeating. I'll write that down. A is equal to negative 0.008 repeating. For the coefficient of the x term, that's easy. It's 1. So I'll write that down. B is equal to 1. Now I'll substitute these values into this formula. And remember, the output of this formula gives you the x-coordinate of the vertex. The x-coordinate represents the horizontal distance. So the answer we get is the horizontal distance, and that's exactly what they are looking for in part B. So let's go ahead and substitute 1 into the formula. We have negative 1 divided by 2 times negative 0.008. And since it's repeating, just place as many 8s as possible. So your calculator assumes that it's 8 repeating. And I end up with 56.25 feet. 56.25 feet. And as predicted, it will be between 50 and 70. And it looks to be a point right there. That's the answer for part B. For part C, they're asking what is the maximum height of the object. Essentially, they want the y-coordinate, or in this case, the h-coordinate, the height, at that x-coordinate. All we have to do is substitute the value that we found, 56.25, into our function, 56.25. And let's go ahead and do that. We have negative 32 bracket 56.25, and that's being raised to the power of 2 divided by 60 to the power of 2. Now that's that first part plus x again is 56.25 plus 10, and we end up with 38.125, which appears to be accurate. It's just under 40. The answer to C is 38.125 feet. And there you have it. That is how to maximize projectile motion functions.